If the rate of dissolution is equal to rate of crystallization, there is an attainment of equilibrium. That equilibrium is called as what? Dynamic equilibrium. Exothermic reactions are favored at low temperature. Endothermic reactions are favored at high temperature. What is the graph for Henry's law? The graph for Henry's law is partial pressure versus what? Mole fraction. Hello my dear students, I am Renuka Ashok, the Department of Chemistry, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. Welcome to third session of the chapter Solution. Already I completed first session as well as second session. Today I am going to explain the third session of Solution chapter. Last session, that is in the second session, I discussed about the units of concentration, molarity, molality, normality, and I solved problems which are related with molarity as well as normality. Today in this solution, I am going to explain one concept, that is solubility. What is solubility? How sugar is dissolved in water. So how it gets soluble in water? Solubility. Next, the factor depends on solubility, and solubility of solid in liquid, solubility of gas in liquid, Henry's law, application of Henry's law. Today's class, I am going to discuss about solubility and the factors which influence the solubility, and I am going to explain two cases. Case 1, solubility of gas in liquid and solubility of solid in liquid. Next, Henry's law and application of Henry's law. Now, solubility. Observe here. When I put oil into water, it is insoluble. When I put sugar in water, it is soluble. Oil is insoluble in water, sugar is soluble in water. Now, I am going to discuss about solubility of solid in liquid, solubility of gas in liquid, solubility of liquid in liquid. Let us consider what exactly solubility. When I consider solute, I am going to add into one solvent. I am going to add a solute into solvent. What happens? The solute particles leave solute phase as well as they are going to mix with the particles of the solvent phase. When solute is get mixed with the particles of solvent, this process is called as dissolution. This process is called as what? Dissolution. Agar what is dissolution? The solute particle leaves solute phase and they get mixed with the particles of the solvent phase is called as what? Dissolution. Now, compounds like sugar, potassium nitrate, ammonium nitrate, salt, they get soluble in water and they are insoluble in benzene, ether, alcohol. Compounds like sugar, potassium nitrate, ammonium nitrate, they dissolve in water, and whereas they are insoluble in benzene and ether. Similarly, the compounds like naphthalene, anthracene, diphenyl, they dissolve in benzene and not in water. So, from these two examples, how can you say it is a concept like, dissolve like, dissolve like, dissolve like, dissolve like. What's the meaning of this generalization like, dissolve like? Polar solutes are dissolved in polar solvent, non-polar solutes are dissolved in non-polar solvents. Polar solutes like sodium chloride, potassium nitrate, ammonium nitrate, they dissolve in polar solvents like water and they are insoluble in non-polar solvents like benzene, ether, etc. Non-polar solutes are dissolved in polar solvents like benzene, ether and they are insoluble in polar solvent. That means like, dissolve like means say that polar solute dissolve in polar solvent, non-polar solute dissolve in non-polar solvent. Thus, dissolution of a solute in given solvent takes place when the nature of the interparticle attractive in the solute and solvent are same. Once again, I will tell you, non-polar molecules are soluble in non-polar solvent. Example, CCl4 soluble in benzene. Polar molecules are soluble in polar solvents. Ethanol is soluble in water. Ionic compounds are more soluble in polar solvent. NaCl dissolve in water. Now, solubility of a solid in liquid. Dissolution, when solute is added to solvent, solute, it will form solution. It will form what? Solution. This is called as dissolution. It is called as what? Dissolution. It is called as what? Dissolution. And this process is reversible. The backward is called as what? Crystallization. Backward is called as what? Crystallization. The forward is called as what? Dissolution. Forward is called as dissolution. Backward is called as what? Crystallization. That is, dissolution of solute in a solvent is a reversible change. If dissolution is the forward change, then the crystallization is the backward change. So, dissolution is forward and crystallization is what? Backward. When a large amount of solid solute is added to given amount of a solvent, initially dissolution of the solute takes place, but as the concentration of the solute particles in the solution phase increases, the backward change, that is crystallization, begins and its rate starts to increase. Usually in the reaction, first dissolution takes place. As it goes on, from the backward side, which one is takes place? Crystallization takes place. Therefore, when solute is dissolved in solvent, the forward is dissolution, the backward is crystallization. Therefore, the solubility of solute in a solvent, it's an example for reversible change. So, at one stage, rate of dissolution is equal to rate of crystallization. Rate of dissolution is equal to rate of crystallization. At one stage, rate of dissolution is equal to rate of crystallization. That stage is called as what? Dynamic equilibrium. That stage is called as what? Dynamic equilibrium. Observe here, when I add sugar to water, it gets dissolved. Backward crystallization takes place. Backward crystallization takes place. If the rate of dissolution is equal to rate of crystallization, there is an attainment of equilibrium. That equilibrium is called as what? Dynamic equilibrium. Therefore, always when solute is dissolved in solvent, forward reaction is dissolution. After crystallization takes place. At one stage, rate of dissolution is equal to rate of crystallization. That stage is called as dynamic equilibrium. Once the equilibrium is reached, once the equilibrium reached, what happens? The concentration of the solute remains constant. The concentration of the solute remains what? Constant. No more solute dissolves in that solvent. No more solute dissolved in the solvent. Okay. So, when at equilibrium, what happens? The concentration of the solute remains constant. Go on adding solute to the solvent. The solute not soluble in solvent. That point, that solution is called as what? Saturated solution. That solution is called as what? Saturated solution. The solution thus formed is said to be saturated. A solution in which no more solute can be dissolved. A solution in which no more solute can be dissolved. No more solute can be dissolved at the same temperature and pressure, is called as saturated solution. Is called as what? Saturated solution. If you add some more solute, it gets soluble. Such solutions are called as what? Unsaturated solution. My dear students, once again I'll repeat, at equilibrium, the concentration of the solute remains constant. The concentration of the solute remains constant. At that moment, go on adding solute. The solute is not soluble in solvent. That solution is called as what? Saturated solution. If some more solute can be dissolved, that is called as what? Unsaturated solution. Now you take saturated solution. In that, calculate amount of solute present in a given quantity of a saturated solution. Amount of solute present in a given quantity of saturated solution at given temperature and pressure is called as solubility. Is called as what? Solubility. Agar what is solubility of the solution? It is the amount of solute. It's the amount of solute present in a given quantity of saturated solution. Present in a given quantity of saturated solution at given temperature and pressure is called as solubility. Therefore, if you want to calculate solubility of a solution, the solution must be saturated as well as it is at given temperature as well as what? Pressure. Therefore, today you heard about two terms. One is saturated solution and one more unsaturated solution. Saturated solution means no more solute cannot be dissolved. Unsaturated means some more solute can be dissolved. Students, when I consider solubility of solid in liquid, so first I want to discuss about effect of temperature on solubility of solid in liquid. Solubility of solid in liquid, the temperature how does affects the solubility of solid in liquid. When solute particles are in equilibrium with solution in dynamic equilibrium, it follows Le Chatelier's principle. According to Le Chatelier's principle, exothermic reactions are favored at low temperature, endothermic reactions are favored at high temperature. Exothermic reactions are favored at low temperature, endothermic reactions are favored at high temperature. It's an application of Le Chatelier's principle. According to this principle, increase in temperature shifts the equilibrium towards the endothermic change and decrease in temperature shifts the equilibrium towards exothermic change. That is, exothermic reactions are favored at low temperature, endothermic reactions are favored at high temperature. Therefore, if the dissolution of solute in a given solvent is endothermic, then its solubility increases with increase in temperature. If the dissolution of a solute in a given solvent is exothermic, then the solubility of the solute decreases with increase in temperature, because exothermic favored at low temperature, endothermic favored at high temperature. How do you identify the reactions are exothermic and endothermic? When enthalpy of solution is less than 0 or it is negative, the reactions are exothermic. When enthalpy of solution is greater than 0 or it is positive, it is endothermic reactions. How do you know? What are exothermic reactions? Reactions where heat is liberated are called as exothermic. Where heat is absorbed, they are called as endothermic. How do you identify exothermic reactions and endothermic reaction? Exothermic reaction, enthalpy of solution is less than 0. For endothermic reactions, enthalpy of reaction is greater than 0, negative as well as what? Positive. So this is about the solubility of solid in liquid. How does temperature affects the solubility of solid in liquid? Solubility of solid in liquid depends upon temperature, but before applying temperature, you have to find out whether the reactions are exothermic or endothermic. How do you identify exothermic reaction? Its enthalpy of solution is less than 0, exothermic. If enthalpy of solution is greater than 0, it is known as what? Endothermic. Okay, so this is how to apply the temperature on exothermic as well as what? Endothermic. Exothermic reactions are favored at low temperature, endothermic reactions are favored at high temperature. So this is the effect of solubility of solid in liquid, that is how temperature influences the solubility. And next was the effect of pressure. No significant effect on the solubility of solid in liquid, because solids and liquids are highly incompressible. Solid and liquids are highly incompressible. Therefore, pressure has no effect. When solid is dissolved in liquid. Pressure has no effect. When solid is dissolved in liquid, pressure has no effect. Once again, I'll repeat, effect of pressure. There is no significant effect of pressure on the solubility of the solid in liquid, because solid and liquids are incompressible. Therefore, pressure has no effect when solid is dissolved in liquid. Now, solubility of a gas in liquid. Example, carbon dioxide dissolved in water to form soda water and soft drink. You observe Coca-Cola. In Coca-Cola, so which gas is added? So which one gas is liberated? Carbon dioxide. In soft drinks as well as what? Soda water, which gas is dissolved? Carbon dioxide is dissolved. And water in wells, rivers and sea contains dissolved air, which is used by aquatic animals for their breathing. Okay, so oxygen get dissolved in wells, rivers as well as sea water. They contain dissolved oxygen. So that is used by aquatic animals for their breathing. The factors which influence the solubility of gas in liquid are nature of the gas, nature of the solvent, temperature, external pressure. What are the 4 factors which influence the solubility of a gas in liquid? Solubility of a gas in liquid is influenced by how many factors? Fourth factor, nature of gas, nature of solvent, temperature, pressure. So nature of gases and nature of solvent. So already we use terminology like, dissolve like, dissolve like. According to this generalization, non-polar gases are less soluble in polar solvent but more soluble in non-polar solvent. Similarly, polar gases are dissolved in polar solvents. Polar gases are dissolved in polar solvent. Polar in polar, non-polar in non-polar. That is nature of gas as well as nature of solvent. Nature of gas as well as nature of solvent can be discussed by using one generalization. The generalization is called like, dissolve like, dissolve like. Next, effect of temperature on the solubility of gas. Generally, the dissolution of gas in liquid is always exothermic. Please, my dear student, remember this as a key point. Okay, any gas, you take oxygen, carbon dioxide, nitrogen, hydrogen, any gas you should dissolve in liquid, it is always exothermic. When any gas is dissolved in liquid, it liberates heat. Therefore, generally when gases are dissolved in liquid, it is associated with liberation of heat. So generally dissolution of any gas in liquid is exothermic. Already you know that from according to Le Chatelier's principle, as you increase the temperature, so exothermic reactions are favored. Therefore, one we can say exothermic reactions are favored at low temperature, And second point, for example, one liquid is there, in that there are gas molecule. When you heat that liquid, what happens? Gas molecule acquires extra kinetic energy and they leave the system and jump into the surrounding. Therefore, don't heat the mixture which containing gas and liquid. If you heat that mixture which containing gas and liquid, what happens? The gas acquires extra kinetic energy and it jumps from the system and goes to the surrounding. That's the reason, my dear student, why soft drinks as well as what? Soda water preserved in refrigerator, that you have to preserve at low temperature, because if you increase the temperature, the gas leaves the system. Because dissolution of any gas in liquid is always exothermic and it is favored at low temperature. Therefore, if you want to increase the dissolution of any gas in liquid, instead of increase the temperature, you must decrease the temperature. Note, solubility of oxygen is more in cold water than hot water. That's why aquatic species are more comfortable in cold water than in warm water. All aquatic species are more comfortable in cold water than warm water. Therefore, what's the effect of temperature on solubility of gas in liquid? Solubility of gas in liquid favored at low temperature. Why solubility of gas in liquid favored at low temperature? Because dissolution of any type of gas, whether it is a polar gas or it is a non-polar gas, is an example for exothermic. Exothermic means there is a liberation of heat. Next, the solubility of a gas in liquid increases with increase in pressure. So, as pressure increases, the solubility also increases. So, Henry's law. So, how the pressure and solubility are related with each other, it can be stated by using one law, that is known as what? Henry's law. According to Henry's law, at constant temperature, solubility of a gas is directly proportional to partial pressure. Solubility of a gas in liquid is directly proportional to partial pressure. As you increase the pressure, the solubility of a gas in liquid also increases. Hagadre, if you want to increase the solubility of gas in liquid, what you have to do? You have to preserve that soft drinks as well as soda water at low temperature under high pressure. That's why soda water and soft drinks bottles are sealed under high pressure. That's why when you open the lid of soft drinks as well as soda water, we'll see a sound called as that is liberation of what? Carbon dioxide, which is sealed under high pressure. Therefore, was the statement of Henry's law at constant temperature. Henry's law is applicable only at constant temperature, not at given temperature. At constant temperature, the solubility of a gas in liquid is directly proportional to partial pressure of the gas. Now you consider solubility of liquid in terms of mole fraction. In terms of what? Mole fraction. Then that partial pressure is directly proportional to mole fraction. So capital X is mole fraction, P is partial pressure. P is partial pressure. Okay. Solubility of a gas in liquid. Solubility of a gas in liquid. If it is a function of a partial pressure of the gas, if you use the mole fraction of a gas in the solution as a measure of its solubility. So when you measure the solubility of this gas in liquid in terms of mole fraction, partial pressure and mole fractions are directly proportional to each other. What is X? X is the mole fraction. If I remove the proportionality sign, I'll write KH into X. P is equal to KH into X. What is P? P is partial pressure, KH is Henry's constant, X is the mole fraction. X is the mole fraction. So what about P? P is partial pressure. P is partial pressure. KH is Henry's constant, X is the mole fraction. Alige partial pressure and solubility which is expressed in mole fraction are directly proportional to each other, where P is partial pressure, X is mole fraction, KH is Henry's constant. KH is Henry's constant. For this Henry's law, when I plot a graph of partial pressure versus mole fraction, we will get a linear graph which passes through the origin. If you draw a graph of between partial pressure of the gas versus mole fraction of the gas, so then we should get what? Linear graph. We'll get what? Linear graph. What is the graph for Henry's law? The graph for Henry's law is partial pressure versus what? Mole fraction. And this KH value, Henry's constant, is directly proportional to temperature. So higher the value of KH, higher will be the solubility, as well as it is directly proportional to temperature. Directly proportional to temperature. Now, what are the applications of Henry's law? Already I explained that from Henry's law. So, you know that if you want to increase the solubility of carbon dioxide, soft drinks as well as in soda water, it must be sealed under high pressure. It must be sealed under what? High pressure. Therefore, to increase the solubility of carbon dioxide in soda water and soft drink, the bottles are sealed under high pressure. And solubility of gas increases with decrease in temperature. Due to this, aquatic animals are more comfortable in cold water than in warm water. So, aquatic species are very active or as well as alive in cold water than in warm water, because cold water really the percent of oxygen is more, because solubility of a gas in liquid is an exothermy and it is favored at low temperature. Now, as you know about scuba divers or sea divers, they carry oxygen cylinder. That oxygen cylinder is diluted with helium. That oxygen is diluted with what? Helium. Why the oxygen is diluted with helium? To minimize the solubility of nitrogen in the blood. Minimize the solubility of nitrogen in the blood. Why you have to minimize the solubility of nitrogen in the blood? Because otherwise that sea diver suffer from a disease called as bend. What is that? Bend. To that, so scuba diver carries oxygen cylinder that must be mixed with what? Helium. Once again, I'll read. Oxygen cylinder used by sea divers or scuba divers are filled with air which is diluted with helium to minimize the solubility of nitrogen in the blood by decreasing its partial pressure to avoid the risk of what? Disease called bends. What is that? Bends. To prevent bends, the oxygen must be mixed with which gas? Helium. Which gas? Helium. Next, as you know, at higher altitude, that is in Chamundi Betta mountain, or when you go to Tirupati Betta, as you go and above mountain, when you climb mountain at higher altitudes, the pressure of oxygen is less than that of the ground level. So this leads to the low concentration of oxygen in the blood. Okay. So the pressure of oxygen is less at the higher altitude compared to ground level. Therefore, mountain climber tissues, there is a low concentration of oxygen. Low blood oxygen causes climber to become weak as well as unable to think clearly. It is not possible to think clearly because of the low concentration of oxygen. When he is unable to think clearly, so that is called as symptoms of anoxia. Symptom of what? Anoxia. So, therefore, mountain climber, they are suffered by one disease that is called as what? Anoxia. Sea divers, they are suffered by one disease called as what? Bends. To avoid bends, the sea divers, when they carry oxygen cylinder, that oxygen should be mixed with what? Helium. In this session, I discussed about solubility terminology, saturated solution, unsaturated solution, as well as two terms, that is two cases when solid is dissolved in liquid, one more gas is dissolved in liquid. Next session, I'll discuss with one more new term, that is vapor pressure of the liquid solution. Next session, my dear student, I come up with new concept, that is vapor pressure. Okay, so next session I'll come up with new concept, vapor pressure. Thank you. Goodbye.